So today we're moving on to Chapter 3, Section 1, Relations and Functions. So let's first talk about what a relation is. A relation is a set of ordered pairs. If you don't know what a set is just a list of things. So if we have a set of ordered pairs, it's just a list of ordered pairs. That's what our relation is. Sets need set notation, so we use these little curly Q brackets down here. We don't want to use parentheses to denote them or brackets. Those are different things. We want to use these little curly Q braces to denote a set. So make sure you use those whenever you're creating your relations. So here's an example of a relation right here. It's just a list of ordered pairs in my set notation. So domain and range, you've probably heard these words before. Let's talk about them a little bit and what they are. The domain is just my set of x values. So every ordered pair has an x value and a y value. So the domain is my set of x values. So for this example up at the top, my x values are 1, -2, 3, and 5. It's just all my x values in each ordered pair. It's the set of first values in the ordered pair. So we write it in set notation right here. We draw our braces for our set, and we list our x values, 1, -2, 3, and 5, and then we close the set with another curly Q bracket. Another way to represent it would be in what we call set builder notation right here. This is the domain equals the set of all real numbers x. This bar means such that the set of all real numbers x such that x equals 1, -2, 3, 5. And I use my curly Q bracket to cut it off. So that's just another way to represent our domain. Set builder notation. The set of all real numbers x such that x equals 1, -2, 3, and 5. So if the domain is our set of x values, that would make our range our set of y values. It's our solution set. It's a set of all of our second values in the ordered pair. So in this example up here, our y values are 2, 1, 1, and 3. We can also say it's our set of answers because our y values are our answers. Our x values are our inputs, our y values are our outputs, aka our answers. So once again, we just represent it with our set, our braces that represent our set, and then we list them, 2, 1, 3. Notice that I didn't write 1 twice, even though it was listed twice up here in my ordered pairs. I only have to represent each number once within my set. Now we can use set builder notation again to represent our range. So our range equals the set of all real numbers y such that y equals 2, 1, and 3. So the domain is my set of x values. The range is my set of y values. There's also some different ways to express a relation. The first way is the way we've seen it already, the set of ordered pairs. So here's our set of ordered pairs right here. The second way to express a relation is using a table of values. You've probably seen this before, but it can be vertical, where you have your x values on the left, your y values on the right. So my first x value is 1, its corresponding y value is 2. -2, 1, 3, 1, 5, 3. So that's one way to represent a relation as a table of values. You could also see it horizontally, where your x values are on top, your y values are on bottom. So 1, 2, negative 2, 1, 3, 1, and 5, 3. So a set of ordered pairs, table of values. That's two ways to represent a relation. The next way is using a mapping. Let me get my ordered pairs over here. 1, 2, negative 2, 1, 3, 1, and 5, 3. So a mapping, I list my x values in that left oval. So I have 1, negative 2, 3, and 5. And then I list the corresponding y values in the right oval. So my first y value is 2. I need to draw an arrow from 1 to 2. We say 1 maps to 2. Negative 2's y value is 1. So negative 2 maps to 1. If you notice though, 3 also maps to 1. So I don't need to list 1 again. I can just draw an arrow from 3 to my 1 over here. And then 5's y value is 3. So I got to draw an arrow from 5 to 3. So that would be my mapping of my relation. The last way to express a relation is a graph. Hopefully you all remember how to graph ordered pairs. My x value tells me to move horizontally, left or right. If it's negative, I go left. Positive, I go right. My y value tells me to move vertically, up and down. If it's positive, I go up. Negative, I go down. So for my first ordered pair, 1, 2, it's telling me to go right 1 and then up 2 and put my point there. So I'm going to go right 1, up 2, and put my point. Next ordered pair is negative 2, 1. So I'm going left 2, up 1 in this case. Left 2, up 1, put my point. 3, 1, right 3, up 1, and then 5, 3, right 5, up 3. So this would be my relation expressed as a graph. So once again, hopefully we all remember how to graph our ordered pairs. That's just one of my few ways to be able to express a relation. Now let's talk about something else that you've also heard of before: independent and dependent variables. The independent variable is always graphed on our horizontal line, aka our x-axis. So my independent variable is my x variable. A lot of times it's time that we're dealing with. That's our independent variable. Our dependent variable is always graphed on the vertical line, or my y-axis. So my dependent variable is my y variable. I hope you've heard this saying before, but it makes sense. A dependent variable depends on an independent variable. That's why it's called the dependent variable. Makes sense, right? So my independent variable can stand alone. It doesn't depend on anything. But my dependent variable depends on what's happening with my independent variable. So on the next slide, we're going to talk about some real life scenarios and discuss which one's the dependent variable, which one's the independent variable. So a lot of jobs nowadays, they are what we call hourly jobs. You get paid by the hour. You work so many hours, you get paid for each hour that you work. So in this case, our independent variable would be our number of hours worked. Oops. And our dependent variable would be the amount of money on our paycheck. So the amount of money I receive on my paycheck depends on how many hours I work that week or that month, however often I get paid. Now the next scenario. Some of you guys might be driving soon, within the next year or so, and there's speed limits that you guys know of. And if you go over the speed limit, a police officer can write you a ticket. The faster you are going over the speed limit, the higher your ticket can be. So in this case, our independent variable would be the speed we are traveling. And our dependent variable would be the price of the ticket. So if I'm going 45 miles per hour over the speed limit, that ticket's going to be a way higher amount than if I was going like 15 miles per hour over the speed limit. So the faster I'm going, the higher the ticket's going to be. So the price of the ticket depends on how fast I am traveling. Now, some of us, we might mow in the summertime. You might mow your yard for your parents or your grandparents. And as you probably know, the more rain there is in the summertime, the taller the grass gets quicker. So our independent variable in this case is the amount of rainfall. And our dependent variable is the height of the grass. The height of the grass depends on how much rainfall there is. The more rainfall there is, the taller the grass gets. The less rainfall there is, the lower the grass is. A couple more examples here. To drive a car, you have to apply pressure to your gas pedal to make it move forward. The more I push down on the gas pedal, the faster the car is going to go. If I let off the gas pedal, the car is going to slow down. So our independent variable in this case is the pressure applied to the gas pedal. My dependent variable would be the speed of the car. So how fast my car is going depends on how much pressure I'm applying to my gas pedal. Like I said, if I push the gas pedal down farther, the car is going to go faster. If I let off the gas pedal, my car is going to slow down. And this last example relates to you guys a lot. So you all are in my Algebra 1 class, and you're graded. You get grades for doing your assignments, taking tests, participating in class, and so you got to give some effort in class. If I give very little effort, I fall asleep in class, I don't do my assignments, I don't study for my tests, most likely my grade's going to be pretty low. But if I put forth quite a bit of effort, I do my assignments, pay attention in class, and ask questions when I don't understand something, study for my tests, and try to do my best on my tests, most likely my grade is going to be higher. So my independent variable in this case is my effort in class. My dependent variable would be my grade in Algebra 1. So my grade depends on how much effort I give in class. If I give a lot of effort, I'm going to have a higher grade. If I don't give very much effort, I'm going to have a lower grade. So hopefully this all makes sense. If you have any questions, please let me know. We do have an assignment. It is called Lesson 3-1 Practice. It's a worksheet that is also on Canvas, so be looking for that. Let's say it's due, we'll have it due on Monday, which is February 8th on Canvas. So make sure you're getting that finished, getting it turned in. Let me know if you have any questions. Y'all have a great day.